So we're going to start a new section of the course where we're going to talk about circles, actually. And circles are one special kind of curve. We're going to talk about some other special curves that before we're through with this chapter, but we're going to start out with circles. And let's just think about how we do graphing. You know, our graphing is based on equations in x and y. We take an equation in x and y, and we find points that satisfy that equation. The graph consists of all the points that satisfy the equation. We've already learned how to recognize many kinds of graphs just by looking at the equations. I give a few examples here on the circles handout. You should be able to look at these equations and have a pretty good idea of what their graphs look like without even plotting any points, just by looking at the equations. Now, if we have an unfamiliar equation, we can always try to plot points by picking values of x, solving for y, or you could pick values of y and solve for x to obtain tables of values that we can plot as points, and hopefully if we plot enough points we can draw a graph. We actually did some of that on the very first day of our course. Now, up to now we've mainly graphed equations that were graphs, equations that represented functions. And we're now going to look at several kinds of equations that are not graphs of functions. They do not satisfy the vertical line test. And also, up to now, we've usually just looked at an equation and figured out the graph from the equation. We started with the equation and figured out what the graph is. What we're going to do now is sort of the reverse. We know what we want. We're going to start out with the graph. We're going to know what the graph is. And we're going to figure out what equation would go with that graph. And that's how we think of circles. So let's start talking about circles now. And so we know what a circle is, this perfectly round kind of curve. The question is, what kind of equation would have a graph that's a circle? So any circle consists of all the points, a fixed distance called the radius, from a given point called the center of the circle. So that the points on the circle form this curve going around. We can apply the distance formula to derive a general form of the equation of a circle. So let's suppose hk, we're thinking of h and k as both numbers here, are coordinates of a point at the center of a circle. So here's my hk. And suppose the circle has radius r, so r is some number. Let xy denote the coordinates of any point on the circle. So I labeled an xy here on my picture, but I could have put xy anywhere around the curve of this circle, because all those points are on the circle and they're all the same distance r from the center hk. So if xy is a point on the circle, the distance from hk to xy must be equal to r. So what I did was I plugged these points into the distance formula, the square root of the difference of the x coordinates squared plus the difference of the y coordinates squared. That's got to equal the distance between those 2 points, which is r. Now, this distance formula equation has a square root in it. What we normally do with circles is we square both sides of that equation to obtain x minus h squared plus y minus k squared equals r squared. When we square both sides, the square root goes away from the left-hand side, and the r becomes squared on the right-hand side. And we prefer the equation in this simpler form. X minus h squared plus y minus k squared equals r squared is the standard form of the equation of a circle with center hk and radius r. Now there's one special case we want to be aware of. And that's when the center happens to be at the origin. The origin is the 0, 0 point in the coordinate plane. So in that case, hk is 0, 0. So if we take our standard form and set both h and k equal to 0, it's going to look like this. And x minus 0 squared could just be written as x squared. Y minus 0 squared is just y squared equals r squared. So that equation of the circle takes a particularly simpler form when we have a circle centered at 0, 0 of radius r. And here's a picture of a circle centered at 0, 0. Now let's start doing some of these exercises on the sheet. So the handout has exercises that we're going to do together in the video. There's a separate sheet of homework exercises. It's posted as a PDF in Canvas. There are no exercises from the textbook on this section, just from the extra handout. And so I copied out the wording of the problems here on my worksheet. So the first problem on the handout is to find the equation of a circle centered at 3, -2 with radius 5. And then we're going to answer the question, does 3, -2 satisfy the equation? Why or why not? So first let's find the equation. Okay? And I have just, you don't have to draw a graph or a picture, but I just did it to help us think a little bit about this situation. So here's the point 3, -2 at the center. The radius is 5. I measured 5 units out. And then I did this all around and drew a circle that satisfies that condition. So that's the circle we're trying to describe in this problem. So we're going to use the x minus h squared plus y minus k squared equals r squared, the general form of the equation of a circle. If it's centered at 3, 2, that's my h and k point. H is 3, k is -2. If we have radius 5, 5 is the value of r, and then I just plug into the formula. So I have x minus h is 3 in parentheses squared, plus y minus k is -2. I have minus a -2 squared equals r squared is 5 squared. And now we're not going to multiply out the x minus 3 squared. Traditionally, we just leave that alone. And I'm not going to multiply out the y minus 2 squared, but I am going to rewrite the y minus a -2 is y plus 2 squared. So notice that this minus 3 corresponds to a h value of plus 3. The y plus 2 corresponds to a k value of -2. Equals 5 times 5 is 25. I'm going to multiply out that 5 squared. And we just stop there. We're going to leave the equation written in this way. And now we got to answer that question. 3, -2 satisfies the equation. And the answer is no, right? 3, -2 is the center of the circle. The only points that satisfy the equation are the points that are actually on the curve of the circle that goes around the outside. So we can say no. And how could we answer the question why or why not? Well, we could try plugging into the equation. So I'm going to take x minus 3 squared plus y plus 2 squared equals 25. If I try plugging in 3, -2, I write 3 minus 3 squared plus negative 2 plus 2 squared. And we're asking ourselves, is that equal to 25? Well, I'm getting 0 squared plus 0 squared equals 25. No way. 3 negative 2 does not satisfy the equation. And that would be my reason why I say no. All right, let's go on to the next problem. Find an equation of a circle centered at the origin of radius 3. So now we could either use the general form or that special case. The origin is 0, 0, so that's the center. That's my HK point. The radius is 3, they're telling us. I'm going to plug into the general form, but you could use that special case if you wanted to. It comes out the same. But I just want to see this one more time. If I plug in 0 for h and 0 for k, I get x minus 0 squared plus y minus 0 squared equals r squared is 3 squared, our radius squared. So that x minus 0 is x. I just have x squared. Plus y minus 0 is y squared. Equals 3 squared is 9. We square the radius to get the right-hand side. And there's my equation of a circle centered at the origin of radius 3. Notice that if you want to identify the radius here, you got to realize the value of r is actually the square root of that number we see on the right. So there's our second problem. Okay, so we got one equation, two equations. Let's move on to the next problem on this sheet is number 3. Find an equation of a circle centered at 2, 1 that passes through the point 4, 2. Now, to find an equation of a circle, we need two things. I mean, we need the center, HK, and we need the radius, R. Well, if the circle is centered at 2, 1, there's my HK. But this business about passing through the point 4, negative 2, that's great, but we need to find R. Because the equation requires that we plug in HK and a value for R. Now let's just think about what the picture looks like. You don't have to draw a picture to do this, but I want to just take a look at a picture. So centered at 2, 1. So if I set up a graph grid here, 2, 1, there's my center. That passes through the point 4, negative 2. 4, negative 2 would be right here. So this is the center. This is a point on the circle. If I draw a line from the center out to the point, that's got to be a radius. That length right there. And what was that other point? That other point is 4, negative 2. This point at the center was 2, 1. Well, the radius is just going to be the distance from 2, 1 to 4, negative 2. And I'm just going to, it's not easy to draw a circle freehand, but I can kind of imagine the circle just roughly being a shape something like so. That's the circle we're describing from this given information. All right, so to get the equation, really all we needed to find was r, and r equals the distance between 2, 1 and 4, -2. So I'm going to plug into the distance formula, where it's kind of like I'm thinking of one of these as my x1, y1 point, and the other as my x2, y2 point. My distance is going to be 2 minus 4, 2 minus 4 squared. And that's the difference of the x's squared plus, actually I put the 2 first, minus 4 squared, 1 minus a -2 squared. And I guess in plugging into the formula, I made the 2, 1 you could say my x2, y2 point, and my 4, -2, the x1, y1 point. If we're strictly following the formula, we could do it either way. And so now let's calculate that distance. So r is going to be equal to the square root of -2, 2 minus 4, -2 squared, plus I got 1 plus 2 squared. So that's the square root of +4 plus 3 squared is equal to the square root of 4 plus 9, or the square root of 13. So in this picture, this radius is actually the square root of 13 units long. That square root doesn't simplify. And so next, plug into the equation of the circle. So I'm going to plug into my x minus h squared plus y minus k squared equals r squared formula, because now I have my value for h and k, which we always had, and I have my r. X minus 2 squared is x minus h squared, plus y minus k is y minus 1 squared, equals r squared is the square root of 13 squared. And so I have x minus 2 squared plus y minus 1 squared. When I square that square root of 13, I get just 13. So I'm not going to multiply out the squares of the binomials in parentheses. I'm just going to leave my equation in that form. And there's our solution to number 3. So the equation of that circle is x minus 2 squared plus y minus 1 squared equals 13. Okay, let's do exercise number 4 on the sheet. Is to find an equation for a circle such that that has endpoints of a diameter at 2, 5 and -4, -3. Now, to find the equation, we need hk, the center, and r, the radius. Neither one of these is the center of the circle. Let's just think about that. Let's draw a picture, a graph here maybe. 2, 5, 2, 1, 2, 3, 4, 5. So 2, 5 would be here. Negative 4, negative 3. Negative 4, negative 3 would be here. Now, if I take my ruler, draw them up, I'm going to connect those up. Endpoints of a diameter, what is the diameter of a circle? A diameter is a line that goes from one point on a circle to another end of the circle, passing through the center. So any diameter is going to have to pass directly through the center of that circle. So 2, 5 is on the circle. Negative 4, negative 3 is on the circle. I kind of have this, somehow, this image, and I'm doing pencil because this is going to be very accurate. My circle's kind of going around like that, right, in this picture. The diameter is going to be, or I'm sorry, the center is going to be on this diameter halfway between these 2 points. So the center is the midpoint of the diameter. The center is the midpoint of the diameter. So what I want to do is find the midpoint between these 2 endpoints. That's our midpoint formula. I'm going to take the midpoint of the segment having, this is like my x1, y1, x2, y2 point. And to get the midpoint coordinates, I take the x coordinates, I add them together, and divide by 2. Take their average. And I do the same with the y. 5 plus negative 3 divided by 2. And that's going to be negative 2 over 2 and positive 2 over 2, which is negative 1 comma 1. That's going to be my HK point. I almost could eyeball it on my graph, but I didn't really trust myself without doing the calculation with the numbers. Here's our center of the circle, and that's the point with coordinates negative 1, 1. That's our H and K. Okay. So we got our HK. We still need an R value. And so how do I get R? Well, R is the distance from the center to a point on the circle. And here in this picture, it's nice to see from either here to here is R, or from here to the other point. I can pick either one of these points. But I'm going to calculate the distance between the center and one of these endpoints of the diameter to get my R. So I have to pick one of the 2 diameter endpoints. The center is negative 1, 1. I got to use that one. And I'm going to pick 2, 5. Why not use more positive numbers here? And I'm going to plug into the distance formula. So take the square root. R equals the square root of 2 minus a negative 1 squared. So this x minus that x, plus 5 minus a positive 1 squared, which is the square root of 2 minus negative 1 is 2 plus 1, or 3 squared, plus 5 minus 1 is 4 squared. So I have the square root of 9 plus 16 is the square root of 25, or 5. 5 is my value for r. And I realize I need a little bit more room here. I'm going to just fold this one sheet. So let's plug into the circle equation, the general form of the circle equation. Now, x minus h squared plus y minus k squared equals r squared. I'm going to have x minus my h value was negative 1 squared, plus y minus k is 1 squared, equals r squared is 5 squared. This becomes x plus 1 squared plus y minus 1 squared equals 5 squared is 25. And there's the equation we were trying to obtain for number 4. That's the equation of my kind of very roughly drawn, sketchy circle there. And what I'm going to do is just tuck this sheet underneath so that we can see all the work for number 4 at once. I got to come out a little bit. There we go. And so there's our equation that for the circle that we wanted in number 4. So that's enough of this video. We'll continue with circle problems in the next.